Okay, so this video is going to explain to you what a composite function is and how you can evaluate a composite function. So first, what is a composite function? A composite function is a function that is composed of two different functions. So for example, you have f of x equals x squared and g of x equals x plus 1. A composite function would be something such as f of g of x, where you're taking g of x and plugging it into the x in f of x. So f of g of x would be saying x plus 1 squared. We're taking the g of x and we're plugging it into the x in f of x. Do you see that? You could also write this as g of f of x. G of f of x, you're going to take the f of x function and you're going to plug it in to the g function, into the x in the g function. So we would say x squared plus 1. We would take the f of x function and plug it in to the x in the g of x function. So we're going to do a couple of exercises similar to that. Here's a formal definition of a composite function. There are two different ways you'll see that a composite function is written. F of g of x, which is this one that I just expressed, and I generally use this notation because I think it reads better. You'll also see this notation. The way you know it's a composite function as opposed to multiplication would look like this. This is multiplication. That means you're just multiplying the two functions together. F of g of x is going to have an open circle right here. A lot of times people call it a fog function because it's an open circle, not a closed circle. So you know it's a composite function if it is an open circle there. Okay, so now we're going to talk about evaluating a composite function. And hold on. Okay, so here are two functions, f of x and g of x. And what I want to do is work through finding f of g of x. Then I want to find g of f of x. And I want to find f of x and g of x. Okay, so what we're going to do, I'm going to kind of color code these. F of x I'm going to do in red. G of x I'm going to do in blue. And I'm hoping that'll help you to kind of see what's going on here. Everything that's neutral I'm going to do in black. So to find f of g of x, I'm going to take g of x and I'm going to plug it into the x in f of x. So we're going to write out the f of x function. So it's, hold on. So we're going to start writing 2 parentheses, and then we're going to plug g of x into the x. So we're going to say 4x cubed plus 1 squared plus 3. Do you see how I did that? And now we could distribute and simplify. In the interest of saving time, we're not going to do that right now, but in your My Math Lab you will need to do order of operations to simplify that. Now let's look at g of f of x. G of f of x, we're going to be plugging f of x into the x in g of x. So we're going to start writing this in blue, and this is going to be 4, then parentheses, 2x squared plus 3, close parentheses, plus 1. So that's g of f of x. Now if we want to find f of x, we'll be in red. And first we'll do a little equal sign here. We're going to now be taking f of x, the function f of x, and plugging that function into the x in f of x. So we're going to say 2, and then in the place of x here, we're going to put 2 parentheses 2x squared plus 3. We're going to close the parentheses and add 3. So do you see how We just plugged f of x, the whole function, into the x in f of x. Same thing for g of x. We're going to take g of x, 4x cubed plus 1, and plug that function into the x in that function. So we're going to say 4 parentheses 4x cubed plus 1, close parentheses, plus 1. So now with this same idea, we're going to look at two functions, f of x and g of x, the same functions from before, and we're actually going to find, instead of f of g of x, we're going to find f of g of 1. One thing you could do is to find f of g of 1 is to take the function f of g of x, which we found right here, and plug 1 in for x here. But I find that another way to do it, a simpler way to do it, is not even have to find f of g of x. If you're looking for f of g of 1, first we want to find g of 1. Okay? So we're going to find g of 1. G of 1 is 4 times 1 cubed plus 1, which is going to be 5. Once you find g of 1, now you're going to plug 5 into f. So we're going to say f of 5. F of 5 is going to be 2 times 5 squared plus 3. So that's going to be 2 times 25 plus 3, which is going to be what? 53. So f of g of 1 is going to be 53. So let's try finding g of f of 1. So again, we're going to start with the inside function, f of 1. F of 1 is going to be 2 times 1 squared plus 3. So that's going to be 5. Then we're going to find g of 5. So g of 5 is going to be 4 times 5 cubed plus 1, which is what? 5 cubed is 125. 125 times 4 is 500. So it's going to be 500 plus 1, which is 501. So that's g of f of 1. Now let's find f of negative 2. F of negative 2. So f is going to be f of negative 2. I'm not writing. F of negative 2 is going to be 2 times negative 2 squared plus 3, which is going to be negative 2 squared is 4. 4 times 2 is 8. 8 plus 3 is 11. Now we're going to find f of 11. So that's going to be 2 times 11 squared plus 3. 11 squared is 121. 121 times 2 is 242. So it's going to be 242 plus 3, which is 245. So f of negative 2 is 245. Lastly, g of negative 1. We're going to find g of negative 1, which is, g of negative 1 is 4 times negative 1 cubed plus 1, which is going to be negative 1 cubed is negative 1. Negative 1 times 4 is negative 4. Negative 4 plus 1 is negative 3. Then g of negative 3 gives us, negative 4 times negative 3 cubed plus 1. So negative 3 cubed is negative 27. Negative 27 times 4 gives us negative 108. So that'll be negative 108. Negative 108 plus 1 is negative 107. So g of negative 1 in this particular problem would be negative 107. So I hope this helps you to understand what a composite function is and how to evaluate composite functions. Let's see. I can shut this video down.